Okay, for today, let's talk about this triangle. You remember that x squared plus y squared equaled 1 squared? Now ring a bell. And that led to sine squared. Notice how I'm squaring the sign. If the square is on the word sine, it's not on the variable because you don't want to square the angle. It's squaring the answer to sine. We could have done this, and you can actually write it that way if you want. It's just slower. So we math people decided to start doing it this way, where it's sine squared plus cosine squared equals 1. Please write that out if you haven't already. So in a typical question where this is going to be useful, they're going to have probably not this exact same statement, but they might just have literally a 1 in the problem. Okay, so like let's say I had cosine squared. Don't write this out, just listen for a second. Let's say I just had cosine squared minus 1. Do you get that I can replace this 1 with sine squared plus cosine squared? I mean, they are the same exact thing. Look, it says that it's the same as 1, so that means this 1 in a problem I could replace with sine squared plus cosine squared. One thing I'd want to do, though, is I'd want to put it in parentheses, like this. Don't write it, just watch. I'm just trying to show you I can swap out a 1, there used to be a 1 here, with a sine squared plus cosine squared. And that would lead to, and for instance, this negative would get distributed to both. Do you get that this cosine squared and that negative cosine squared would cancel each other out? And you'd just be left with negative sine squared. All right. So you got to get used to not just seeing this and thinking, oh, I can replace it with a 1. But you can take a 1 and replace it with all that. Okay. So what else could we do with it? Well, there's two other ones that I need to show you where they come from. They're on your sheet, but I'm going to try to show you where they come from. If I divide everything by sine squared, again, I almost never say this. I don't need you to copy this. It'll just take you too long to copy it. But just pay attention. Do you get it's legal for me to divide everything by sine squared? As long as I do it to everything. It's kind of like dividing everything by 1. You can do that. And dividing everything by 6. You can do that. If I had 1 plus 2 equals 3, I could divide everything by 3 if I wanted to. I don't know if you've ever thought about that. 1/3 plus 2/3 equals 3/3. See, works. You can do that to any equation. So I'm going to divide everything by sine squared. And then the cool thing that happens is sine squared over sine squared equals 1 plus cosine over sine. Ooh, I feel like that's kind of familiar. It's like tangent, but it's not quite tangent. What is it? Cotangent. Very good. 1 plus cotangent equals, 1 over sine squared? It's the flip. What's the sister one of that? Cosecant. Very good. CSC squared. And just look at what I have left. It's a new fact statement. 1 plus cotangent equals cosecant. That's where it came from. We took the other one, sine squared plus cosine squared equals 1, that I told you where it came from the triangle. We can know that that's a fact because of right triangles. And now we're dividing everything by sine squared, and we get this. Now, back in the day, we used to make the kids memorize these. I still am a little conflicted because I feel like I get the argument that you guys can look things up in the real world. The internet's there. Now we've even got ChatGPT. You can ask it questions. It would be able to tell you, like, what are the identities. So we give you this sheet. But we used to make kids memorize them. And there are still cases where that would be handy, like on the ACT, where they don't give you a sheet. You have to know them out of your head. But I had a nifty little saying that helped kids remember this one. The one with the coat is cozy. You see where I got that? Coat. The one with is like plus, the coat is CSE, cozy. I know it's a little bit of a stretch, but it was a fun way to remember. Okay, now that's one of the ones on your sheet. Do you look at the little half sheet that I handed out? You just look for it for a second. Just verify that one with the coat is cozy is on there. They just happen to put the coat first. Doesn't really matter where you put that. All right. Then there's one more in the middle that I'm going to show you where that comes from. I bet you can figure this out. I just divided everything by sign, and I got this cool new statement. What do you think I'm going to do next? Divided by cosine. Now you don't have to write this. Again, I almost never say this, but it's going to be a whole lot of writing for something that's just on your sheet. What is sine over cosine? Tangent. And that's on your sheet. Tangent, notice it's squared, plus cosine over cosine is 1. The one with the tan is 1 over cosine, which is sec. And I'm going to say it this way because we really now know that tanning is like purposely going out to fry your skin is probably not a great idea. Increase in sun cancer and or skin cancer and all that stuff. So I'm going to say if you're a skin cancer doctor, the one with the tan is what you seek. Give it a there. One with the tan is what you seek. Okay. Again, you don't have to memorize them. You're going to have this sheet. Yay. We are enabling you to not have to memorize things. The bad part about that is, did you know that memory is a muscle? Okay, it's not a physical muscle, but it's like a muscle in that if you don't use your memory, it gets weaker and weaker and weaker. And that's why I would argue that maybe there's a little element of kids' memories aren't as strong as they used to be because, true or false, you guys don't have to memorize any of your friends' phone numbers, do you? You put it in the phone, it's just there, automatically there. I had to memorize all my friends' phone numbers. I had to memorize a lot more stuff than you did when I was a kid, and that meant my memory was worked more, and that meant it's stronger. Those people that are the memory champions that actually can take a deck of cards, you can give it to them, 52 cards in a row, and they can literally in 1 minute memorize the order of those cards. They get the deck for 1 minute and look through it, and they memorize what order they're in, and they can go back and give you 52 cards in a row. It's insane. And you know how they get that strong? It's just work. It's just like a person who goes to the gym and lifts a lot. The person who memorizes a lot gets stronger and stronger and stronger. My point, I know, this is a little bit of a rant, but I'm just feeling like we as a society, we got to figure out how to strengthen people's memories because we're weakening them by giving them so much information just instantly off your phone. We all do it. It's a part of life now, but it is having a consequence. And I think you guys probably have a little weaker memories than people did when there wasn't that technology. You're better at other things, though. You're incredibly good at just knowing, oh, I can look that up, and you find it, and you get the information so quick. In the old days, if I was sitting in a classroom and I was like, I wonder about this, I could not go look it up anywhere. You have to go find a book. Find the right, page in the book, and then finally find the answer. No, it's so much harder to find information. Okay, so anyway, that's where these come from, and these are called the Pythagoreans. Let's see exactly how you would use them. So this is the part where I want to actually get into the homework. Like this, I know it's incredibly early to be in the homework, but there are so many homework problems there that all work nice. If I try to make ones up for you, that's kind of dumb. We've already got a set of ones that all work. And I never assign the whole thing anyway, so I'm just going to do a bunch of these and then have you finish the worksheet as your homework. All right? And once you get the idea of how these look and what your options are, they're not that bad. I totally get, though, at the beginning when you're new at this, you look at problem number 1 and you're like, I don't even know where to start. I have no idea what I should do. And after we do a few together, you'll start learning what to look for. And Again, it's I really can assure you that these get easy later, but at the beginning they're challenging. I mean, I would have said the same thing about inverse trig, and on the last test, you guys averaged an A, so that's fantastic. Well, okay, it's an A minus, I think, but it was a really strong result. So after a while, you'll get good at this. All right, so they're asking me to prove one of the things that's just on the sheet. 1 with the tan is equal to secant. So how are you supposed to, like, prove that? Well, it's not that hard. Do you remember the rules? You don't touch one of the two sides, okay? And then we have to show work, and then it has to end with a statement that's exactly the same on both sides. All right, so which is the more complicated side? I'd say this one. That looks more complicated to me. So then I could go a really complicated roundabout way to prove this thing. I could replace 1 with sine squared plus cosine squared, and then eventually, after a ton of work, I could get to secant. Or I can just, like, there is a Pythagorean identity on the sheet that says 1 plus tangent is secant. That right there is secant. It's just on the sheet, like it says that. So I can just go right to secant squared equals secant squared. This is actually a pretty dumb question because it's too easy. It's like confusing, it's so easy. It says right on the sheet that you can replace tangent squared x, or theta, sorry, plus 1 with secant squared. So since it says that, that's right on the sheet, I can replace this with this. All right, there's number 1, a little too easy. Let's go to number 2. All right, the one with the code is cozy. Isn't that one of the things that's right on the sheet? So again, you can replace this with this. And it's a little too easy because there's like, it's just, this gets replaced with that. It's just too easy. All right, they'll get harder, believe me. Now, this is not on the sheet. There's nothing on the sheet that says exactly that. Okay, so now we have to actually think. So what's the more complicated side? Sine squared or 1 minus cosine squared? Well, I'd say this is a little more complicated. So we'll mess with that side. And we'll leave this sine squared alone all the way to the end. Now, either this or this can be swapped out for something. What do you think? I can replace the cosine squared with something. Like I could put in, well, let's just think about the options. I could put in 1 over secant. Is that going to like help me get to sine? Doesn't feel like that's going to help. So I'm going to reject that option. Did you figure it out?
Yeah.
What should we do?
You can't touch the sides, right?
You're going to leave the sign alone. We're going to just leave this all alone.
Would you put in sine squared plus cosine squared into the 1?
Yes, this 1 right here can be replaced with sine squared x plus cosine squared.
And then the cosines cancel out and the sine equals.
Yes, and I'm just going to copy this down. Minus cosine squared. And yes, this and this are opposites, so they just cancel out. So I'm left with sine squared. Do you remember me saying that I was going to at some point replace a 1 with a sine squared plus cosine squared? See? That makes sense? All right. Number 4. Not on the sheet. There's nothing on there that just says that. Could you do the same exact thing? Yes, you could. I'm not going to do it. You do it. Replace this with what that's equal to. It's right on the sheet. And again, almost a little too easy, but we're working up to it. They get harder. So Claire, what are we replacing the 1 with?
Sine.
Sine squared. Keep going. Plus cosine squared. And then I'm just copying this down. And then, do I want to replace this with a 1 again? No, because then, I was kind of dumb. Take out the 1 and then put the 1 back in, so I don't want to do that. Nate, what's next? Sine and the negative sign are going to cancel out. Nice. Leaving me with just cosine squared. And that's what I was supposed to prove, and it worked. How do I know it worked? Because I got the exact same thing here and here. And each of these steps was a legal thing to do. You're either like canceling something or you're replacing something. Like when I replaced the 1 with sine squared plus cosine squared, all of that made sense because it was all right on the sheet. And then this sign canceled the negative sign. All right. Now I know there's going to be some where you're going to be like, I don't know what to do. But I think number 5 is definitely doable because it's right on the sheet. You can replace this 1 with something strategic. Okay. And it's right off the sheet. It's not sine squared plus cosine squared, though, because think about it. If I put a sine squared and a cosine squared, neither of them is going to cancel with the secant, is it? All right, so now I don't want to just turn you loose and say, oh, from here it's going to be like you're going to be fine. There's going to be stress and challenges. So let's really dig into number 5 quick. If I don't replace the 1 with sine squared plus cosine squared, we have to start getting more creative with the sheet. Do you get that I want tangent at the end? So do you get I should replace the 1 with something like tangent? Like I need something to go in there so that I'll get tangent at the end. So do you see anything that has a 1 and a tangent in it? I do. I'm going to write it right here. Tangent. This is just me taking notes off the sheet. Tangent squared. I'm going to change it to an x. The sheet's in theta, but our problem's in x. So I'm just going to change it to an x. Plus 1 is secant squared. This is just me saying, I think that's the one I'm going to pick because it has a 1 in it and it has a tangent in it. So that's probably it. But this is where it steps up a notch where you can't just find something on the sheet and stick it in. You got to think. I can replace that 1 with what? The 1 isn't alone here. But would you agree we can get the 1 alone? If I could get the 1 alone, I'd know what I could put in. So, if I was going to get that 1 alone, how would I do it? Subtract tangent. Very good. Now, everybody, catch up to me. Write this down. This is important. This is the meat of the lesson for today. It's not just pulling things in off the sheet. It's rearranging the things on the sheet. Because look what we did. We now figured out that 1 can be replaced with secant minus tangent. It's not on the sheet anywhere, or is it? It's on the sheet, it's just rearranged. See what happened there? I took something from the sheet. This right here was on the sheet. And then I just rearranged it. And I said 1 is now secant minus tangent. So is that something I can do from the sheet? Yes. You can say that wherever you see a 1, you can put secant minus tangent. And that is going to work. Because see, when I replace this 1 here with a parentheses, secant minus tangent. And I bring down this is just copying down. Then, do you see how the secant and the minus secant are going to cancel each other out? Now, this negative here really gets distributed. Do you get that that's not negative tangent left, but the negative goes on to the negative tangent and makes it positive tangent? And that's what we wanted to happen. So at the end, you look through your proof and you go, did I just leave one side alone? Yes, I left the tangent alone. And when I did this cancel here, I'm left with negative, negative tangent, which is tangent. And so I know I did it right when these end up being exactly the same at the end. These all have to be the same because you leave one side alone. And this work part right here, that's where all the magic happened. That's the hard part. So what did I do? I went to my sheet, found something that involved what I needed. I needed a 1 to be associated with a tangent, and then I rearranged that thing. That is huge. It's going to happen on your test. You have to be able to do that. So we're going to stop for just a minute. We're going to go out to just look at that. So please find a blank spot again. I know some of you are just going to want to jump into your homework and keep going. Please don't. Come with me onto a blank spot and write this. Sine squared plus cosine squared equals 1. So you can rearrange that. And I now, of course, I can put in cosine squared plus sine squared for the 1, but even more important, I could, everybody, subtract cosine squared from both sides and see what happens. If we made a sheet that had every possible identity rearranged, your sheet would be like monstrous. So this is what you have to be able to do, is take these facts, like the blue thing I wrote, which is on the sheet, and you have to like, well, if I subtract cosine from both sides, then I'll have sine squared equals 1 minus cosine squared. And that is a legal substitution then. Do you get that wherever you see sine squared, you could put 1 minus cosine squared? It's just as much of a fact as this blue one is. It's just rearranged. All right, one more like that. Would everybody please take the same exact equation, sine squared. I know it's a bit of a pain. I asked you not to take notes earlier so when you get all fatigued. Sine squared plus cosine squared equals 1. And now this time subtract sine squared from it, and you'll get another fact that you can use on the test. Subtract sine squared. So wherever you see cosine squared, you can put 1 minus sine squared. It's a rearranged fact. So this, whenever you see cosine squared, you can put in 1 minus sine squared. Wherever you see 1 minus sine squared, you can put in a cosine squared. because it's just as much a fact as the original thing. Let me just give you an example of this in a different context. If I said 25 divided by 5 is 5, could I rearrange that and times both sides by 5? And that would mean that 25, because these two cancel then, right? If this was a divided by 5 and this is a times 5, equals 5 times 5. Do you agree the original fact was a divide and the other one is a times, but they're both facts, they're just rearranged, you know? It's kind of like if I said 1 plus 7 is 8, so 8 minus 1 is 7. That's also a fact, right? I just rearranged it. So it's kind of like that, except I started with this red one, which I know is a fact because it's on my sheet and I proved it. And then I subtract signs, so this must be a fact. And that's what you can use then. It's kind of like a derivative of it. Well, I'm not sure if you know what that means, but it's actually a good math example. Math derivatives are coming in calculus, but you'll learn those later. So there's another, the derivative just means like it's kind of comes from this fact here, comes from this fact here. All right, let's get back to our sheet. And I think we left off, we had just done number 5. Let's go to number 6 here. I can replace this 1. There's something on the sheet. It's not sine squared plus cosine squared though, because then if I do put that in, it's cosecant isn't going to cancel in with anything, so that sine squared plus cosine squared isn't the 1. Try to figure out which of them has 1 and cotangent in it, and use that. Alex, can you read me the fact that has 1 and cotangent in it?
Tan squared plus 1 equals.
That doesn't have cotangent. Cotangent.
Sorry,
That's right.
Cotangent squared plus 1 equals.
Cotangent squared plus 1 equals cosecant. Yep, that's the one. Now we need to rearrange it. I want to get the 1 alone so I can put in something for the 1. Jack Sexton, how do I get the 1 alone in this statement here? Correct. And that means that 1 is cosecant minus cotangent. That's a fact, just as much as the original fact. It's just like, it's a derivative of it. This is a fact because it came from the other fact. So I can replace that 1 with cosecant minus cotangent. Parentheses are huge in this unit, by the way, people. Because otherwise, if you don't have that parentheses, the negative will only go on the first thing, and it won't work. And this side I'm just going to leave alone. And look at that. This and negative that are going to cancel. Making sure I'm doing this right. Negative, that leaves me with cotangent. Yep. This negative of the negative makes it positive cotangent. And that's what I was trying to prove. Because it says cotangent, it equals cotangent. Sweet. Do you get that this one cancels this one? All right, now this next kind is a whole new category on the sheet. They're called cofunctions. Haha, that's right. I remember this. We are skipping that section. Yay. We're not doing cofunctions because there's a whole list of them and your sheet would be twice as long. And we decided that the cofunction ones aren't something that we're going to expect you to do. So these are like, again, if you had a twice as big a sheet, that would be on the sheet and you'd be able to swap it out for something. But yay, not on the test. Yay, cancel it. Cross that off, cross that off, cross that off. And now we're up to problem 11. And if you'll notice in the title of the worksheet, we were supposed to skip 7, 8, 9, and 10. And that makes sense because there's nothing on our sheet that would be able to do those. Back to proving. And all of the rest of these are doable except for 17 and 18 because they have the cofunction thing in them again. Which we don't have there's nothing on the sheet that'll help us. This part right there. Oh, thank you. Yep, there's another one in there right there. We don't have a list of those. That's out. Okay, so we're left with those 1, 2, 3, 4, 5. Do you get how rare it is to only have 5 problems assigned for homework? Why would that be? Especially with this much time. Because these are hard. These are a challenge. And I really, really think this is a good one for you to work through with a partner. So, I'm going to ask you for the rest of the hour to work together on these. And there'll be moments like you'll go, oh, we can swap this out for 1 minus something off the sheet. You have to rearrange stuff on the sheet. We can swap this one out for this. And then it'll all work out nice. And the person that helps you with that is going to be vital. All right. So, can expect these are not going to be super like, oh, that's easy. These are going to be like real challenges. That's why there's only 5 left. All right. These 2 rows, please slide next to each other. These 2 rows, please slide next to each other. All right, work hard to the rest of the hour. I am going to help you just start number 11. If I were you, I would multiply this thing out, this negative, and then I would rewrite it. And then I would look for something on the sheet that involves secant and tangent, because obviously you have a secant and you have a tangent. And there's also something on the sheet that involves cotangent and cosecant. So grab that thing off the sheet, maybe write it off to the side and go, oh, this one seems like it's important. Cotangent plus 1 is cosecant. And maybe you can just do a direct swap. I see cosecant, so I can put in this. Or maybe you'll have to rearrange it and like get cosecant minus cotangent together, and maybe you subtract something from both sides first. I'm not saying on this one what you should do. I'm just trying to say you either do a direct swap right off the sheet, like, look, it's a fact, it's on the sheet, I can do it. Or you can rearrange it by like subtracting cotangent from both sides. And now I have cosecant minus cotangent. What if that was on the sheet? What if cosecant minus cotangent was up there? Then I could swap it for 1. And that'd be awesome. Okay, so you can either take things direct off the sheet, or you can do something like subtract something from both sides and use what I would call a derivative of it. All right, so this is the part where you need to fight through this with your partner. If you get completely stuck, I am going to post an answer key. Now, I really thought this through because some teachers won't post the answer key for these. You know why? Because kids get stuck right away. They just go right to the answer and they just copy it. Okay, I really need you to understand. I'm going to post the answer key, but if you just copy the answer key over, you aren't going to learn it. You have to struggle with this and try to figure them out really hard. And if you get just so stuck you have to look at the answer key, please just look at one step. Just look at like the first step. Don't just copy the whole thing. Just copy the first step and then see if you can do it. You know what I mean? If you just give up and copy the answers over, you are going to fail the test. just look at the answer key different as a way to give you, oh, the next step is this. Just look at one step. In fact, if I had an answer key that only had one step, that would be the perfect thing to be posting right now. You know what I mean? So just give yourself a hint when you look at the answer key. And it's not posted yet, but I'm going to post it in a second. All right, get to work hard, struggle through these.